Hey everyone, in this video we're going to talk about exponents and certain properties that we can use with them. So the first property or rule we'll talk about is called the product rule. So let me write it out. Product rule. And this basically says that if we're multiplying x to the a power times x raised to the b power, this is the same as x raised to the a plus b power. So let's give a quick example. Let's say we had 3 to the second power, and we're multiplying it by 3 to the first power. So normally you could evaluate this. You could evaluate 3 to the second power, which gives you 9. And you could evaluate 3 to the first power, which is just 3. And 9 times 3 just gives you 27. And that is the correct answer. This evaluates to 27. But there's a way to do this with the product rule. And what we can do is recognize, hey, we're multiplying two numbers with exponents. And the important thing is that they have to have the same base right here. They both have a base of 3. If they didn't have the same base, then the product rule wouldn't work. But they do in this case, they're both 3. So we could say, hey, let's apply the product rule. So this is the same as 3 to the power of the sum of their exponents. So 2 plus 1. And 3 to the power of 2 plus 1, that's 3 to the power of 3, which gives you 27 as well. And that's another way of getting there with the product rule. So let's give an example of the product rule with variables, because that's what makes this rule so powerful. We can also use it when variables are involved. So let's say we had x to the power of 3 times x to the power of 100. Well, we can use the power rule on this as well. This is x to the power of 3 plus 100. 3 plus 100. And right here, this is x to the power of 103. And that would be the answer there, x to the power of 103. And that is the product rule. So let's move on to the next one. And the next rule is very similar. It's called the quotient rule. Quotient rule. Let me write it out. And again, it's very similar, but instead of multiplying two numbers, we're going to be dividing two numbers. So x to the a times x, or apologies, x to the a divided by x to the b. This is the same as x to the a minus b. So let's do a quick example. Let's say we had 3 to the power of 100 divided by 3 to the power of 98. Now, 3 to the power of 100 is a massive number. I'm not even sure your calculator can calculate that. And so is 3 to the power of 98. That's also a very large number. So evaluating them first and then dividing them is going to be a very difficult task. But luckily here we can use the quotient rule. We could recognize that they have the same base of 3, and then we can use the quotient rule. This is the same as 3. Let me switch colors. Use green for that. This is the same as 3 to the power of 100 minus 98. And what is 100 minus 98? That's 2. So this comes out to 2, 3 to the power of 2. So 3 to the power of 2. 3 to the power of 2 is just 9. There we go. We solved this. 3 to the power of 100 divided by 3 to the power of 98. That equals 9, and we solved it using the quotient rule. So that's how we apply the quotient rule. And let's talk about the next rule, the power rule. So let's scroll down a little bit. And the power rule is, let's say we have, let me use a different color. Let's say we have x to the power of a, and all of that is raised to the power of b. This is the same thing as x to the power of a times b. And let's give a quick example. Let's say we had 3 to the power of 2, all raised to the power of 2. So let's use the power rule here. 3 to the power of 2 to the power of 2. This is the same as 3 to the power of 2 times 2. And 2 times 2 is 4, so 3 to the power of 4. And that would give us 81. Now, to understand why the power rule works, let's write it out a different way. 3 to the power of 2 to the power of 2. Well, whenever we're talking about exponents, exponents is just repeated multiplication. That's all it is. So 3 to the power of 2 to the power of 2, that is just really 3 to the power of 2 times 3 to the power of 2 times. We're multiplying it twice because our exponent here is 2. And then if you look at this, 3 to the power of 2 times 3 to the power of 2, well, we're back to our product rule, which is the first thing we learned. We're multiplying two numbers with exponents with the same base, 3 and 3. So this is really just 3 to the power of 2 plus 2. So 2 plus 2 is 4. And that gives us 81 as well. So that is how the power rule works. Let me erase all these. And let's talk about some special exponent rules. So zero exponent. So let's say we had 3 to the power of 0, 100 to the power of 0, 1,000 to the power of 0. All of these equal 1. And that is because any number x, the power of 0, equals 1. A 0 exponent means the number will evaluate to 1. Now there's one exception. As long as x itself is not 0. Because 0 to the power of 0 is undefined. And that is something we can't do in mathematics, same as dividing by 0. 0 to the power of 0 we can't do, but any other number to the power of 0 is 1. So that's the 0 exponent rule. Let me erase these. Let's just write it down. That is x to the power of 0 equals 1, as long as x is not 0. Perfect. Let's talk about negative exponents. So negative exponents. So let's say we had x to the power of negative 2. How do we deal with this? Well, this is the same as 1 divided by x to the 2. So to write it more generally, let's say we had x to the power of negative a. This is simply 1 over x to the a. That is what a negative exponent is. It's 1 over x to the power of to that exponent. And to give a quick example, let's say we had 3 to the power of negative 2. This is just 1 over 3 to the power of 2, which is 1 divided by 9. 1/9 is what this evaluates to. That's the negative exponent rule. And let's talk about one of the last things, rational exponents. But what if our exponent is a fraction? So rational exponent. Let's say we had x to the power of a over b. What does this mean? This is the b root of x to the a. So this will make sense through an example. Let's say we had 144 to the power of 1/2. Using this rational exponent rule, this is the same as the square root of 144 to the power of 1. But 144 to the power of 1, of course, is just 144, and the square root of 144 is 12. So 144 to the power of 1/2 is just 12. And that's how we deal with rational exponents. So those are the rules regarding exponents and the properties that we can apply to them. And please let me know if you have any questions down in the comments below. I really hope this helps, and thank you for watching.